Give it up.
Me, ready? All right. Hello, I'm Mike Durand. I'm a cloud architect here at Kenzan. Just to start real quick, the main premise of this is over the last year, Kenzan has seen a lot of clients looking to go to Azure. So kind of we've been developing some skills, and some really the entire company's been upskilling to get that proficiency. So what we're looking to do is share some of those ideas we come up with our clients. And I've already seen some questions around people curious as to why Azure, what are people looking at. So feel free to answer those questions during the presentation if you want, but keep them coming for sure. So continuous delivery. So a lot of people that are developers know about CI, efficiencies there, doing builds, repetitive. So it's been not really new, but over the last 2 years you see a lot more in continuous delivery. So as we go to our clients and we look to see what are ways to be efficient as far as building infrastructure, deploying to VM scale sets or containers or AKS or Kubernetes stacks. We kind of been just kind of looking at patterns. We have some clients on AWS, some on Azure. What are common tools that we can use across both? So this is kind of like the spiel you give, but developers more efficient and reduction of tech debt. Well, really, what makes them efficient is less dependency on operations, less red tape, less worrying about the infrastructure itself, letting them be developers. When you talk about operations, less firefighting, more innovation. When we look at cloud migrations, a lot of companies and people are worried about their jobs as far as I'm a DBA or I'm a sysadmin, what am I going to do? Well, continuous delivery is with infrastructure as code, with things like Ansible, building VMs. It really allows them to do what they're good at, what they went to school for, what they trained for. We find a lot of them are really stuck with provisioning, building VMs, doing things that are just side work or busy work, versus focusing on true databases or truly securing the server. So once again, they get focused on their true skill set. QA, elimination of environment issues. You talked about immutable infrastructure, being able to build, nightly builds on triggers of CI pipelines. Sadly to say, there'll always be bugs, so it's not like we're going to get away from anything there. But it does certainly help with the common mistakes that you see from user error between environments. You have dev, QA, and production. Well, when you use infrastructure as code, the same code gets deployed through all three. You use properties files and parameters to just differentiate them, so you have less human interaction. And ultimately, the business impact of features reach the market faster. So when these teams get more efficient, go through these cadences, less manual intervention, things get done faster. So the tools we're going to focus on today, like I said, a lot of clients have been asking for Azure, but we do a lot with Terraform. So we've been focusing at Kenzan writing Terraform code for the last probably, I'm only here for a year and a half, but people before me, I've seen platform engineers pump out platforms in a week type of thing, and it's been very impressive. And then you see components like Packer. So yeah, I guess you could kind of say we like HashiCorp here. We even have a guy in Denver, we call him Mr. HashiCorp. But we also want to be able to use some of the cloud native capabilities of the cloud provider. So as we look at Azure itself, we look at things like Azure Artifacts, Azure Pipelines, and then the DevOps component of project stuff is Azure Boards. So this cycle that we put together here allows you to do things like create Packer images, golden images, and I'll go through each tool and not worry about what provider you're on. So you create a process, you build your images, and no matter what provider you're on, you can use that. Terraform, infrastructure as code. They have multiple providers. They allow you to be able to build code and build infrastructure based on specs, not so much what provider you're on. So you do have to, worry about modules per provider, but overall, you can then it's just code, so you can manage that. So the first one in the line is Azure Artifacts. Some of the things to consider here are, and I have a diagram that kind of shows the flow, so as I go through them. So Azure Artifacts, the benefits really are, allowing you, feeding your team to be able to automate their things like NPM packages, NuGet packages, Maven packages, and also third-party tools. One of the things we see a lot is I have an image that I'm going to build for my application. I need to go get Tomcat. I need to go get Nginx. Well, if you go to public repositories, what happens? You're vulnerable to whatever they have, or somebody pushed something you don't want, or even there was a case a couple years ago where somebody took down a repo, and now hundreds of thousands of builds failed because it's no longer available. So those dependencies on your code, while they're free, they do have that risk. So Azure Artifacts, what it allows you to do is basically separate yourself from the public and make at least your own private area. So what we find clients doing is taking Nginx, removing port 80, removing any TLS less than TLS 1.2. So now you can create your standards in your golden image, and that way when the application goes to deploy that code, this foundation is already set for them. So really, it's that double managing your archives, managing your pieces there. Packer, the main thing with Packer is the ability to manage your operating systems, security patches, standardize on specific images per application. So what we end up really doing is creating machine images. That machine image can be either an Azure or an AWS machine image. And essentially what you would do is you would then call your Terraform code to then build that infrastructure out in your CD pipeline. And of course you can use AWS or Azure templates or anything like that, but now you're tied into that model for that cloud provider. So HashiCorp's Packer allows you to build images that are agnostic to the cloud and just truly create an image that's right for your application. Also allows you to do things like configurations for custom tools, pre-installed agents. Examples like that is if you're going to run an Azure VM, you may want to put your application insights agent on it. So your application teams don't have to worry about all these extra layers that you're putting on it. They basically, once again, are just responsible for putting their code there and configuring it. So what are the outcome here? Automated immutable environment, focus on code, not maintaining images, self-service model, once again, less dependence on operations, and of course, no API keys or passwords in your images. And you'll see in the pipeline here how we allow things like Azure Key Vault and properties files and Terraform itself to be able to go get your secrets. And I don't actually show that in anything, but that's kind of the main premise that you don't want to have those pieces in there.
And Mike,
yep.
Did you say at the beginning that if people have questions, they should just raise their hand and jump in? Or are we waiting to...
I can stop, yeah, sure, anytime.
Okay, cool. I just wanted to check.
I'm saying a lot, and I go fast, so feel free to stop. How long do I have this? I'll be done in 10 minutes. No. Infrastructure as code. Once again, I mentioned how we use a lot of this at Kenzan. An example, we had a developer for a local company come up, learn Terraform, build a Kubernetes stack in a week or two, and hand that over to the customer, and they were up and running. Obviously, there is some learning there, but it just shows to all the good success stories that you now allow your development teams to less dependency on the infrastructure, just focus on their code. Once again, with Terraform, you can use cloud agnostic, and that's kind of funny with Terraform because there are cloud providers, and you do have to write code specific to the way the cloud providers lay out their infrastructure. So things like security gateways or VM structure. But the key part is what we typically do is break our Terraform code out into modules, and then what we do is we have a main for each app, and then that calls individual modules for the provider. So your main structure for your application can stay the same, you just call different modules behind it. A good example of that is if my application needs, a network interface or a disk storage, whatever it may be. Really, what you're doing is you're defining your variables, your tags, and in your basic parameters. And then no matter what your main wants to call, it's just going to call the cloud provider specific modules. And that's how we've been managing that. And ultimately create immutable infrastructure. So what this really goes towards is every build requires a full build of the stack. So we don't reuse hardware, we don't reuse VM images. We basically build the entire environment from scratch every single time you deploy. What this allows for is the ability to, less manual updates. I mean, and that's everything from patching. So as you looked at Azure Artifacts and Packer, every build you create a new Packer image. So you build it, create the images, and you deploy. Full stack. Tear the other one down, blue, green, whatever you want to do, canary. There. Azure Pipelines. So the last piece is, what's the glue that puts it all together, right? We are big fans here of, I was just talking to somebody about it. Nicholas Park stuff. Spinnaker, yes. I knew it. Once again, open source product, but it's one of those tools that enterprise-wide works great. When you start trying to scale it down, it does have a lot of challenges there. So a lot of our clients want to still take advantage of the cloud provider. So one of the nice things about Azure is the pipelines. And what you'll see is all we really are doing is putting the pieces together here. It's not truly anything more than just the building blocks and structure. One other thing I do have later on my demo here is kind of showing you how you can stand up this environment quickly. And one nice thing about Azure Pipeline is you get 10 free pipelines. So you can actually go in, create a free account, and you can run 10 pipelines to play. So, and I do give you some demo links later on to be able to work with. Okay, so how does this all tie together? Some of the things you want to look at is, we talked about your CI over here, and basically what you end up having is your application outputs some type of image, whether that be a WAR file, a jar file, some type of application image. From there we go to Azure Artifacts. We talked about our Yum and PM repos, and then we have our platform repos on the side of that, and that basically manages those packages and gets you access to all those. The next speed then is you start your first of 3 pipelines here. The first pipeline, what it does is it starts building the infrastructure. So the first thing you're going to need is you're going to need a container registry. You're going to need a place to put your disk images. You're going to need databases for your application. So your first part of eliminating operations is to automate your infrastructure builds. So one of the things we focus on is defining this up front. So then you have, you don't worry about your passwords, you don't worry about your certificates. All that gets done in this first pipeline here. The next step in the pipeline would be to build your actual disk image. So once you know your network interfaces, you know your certificate bases, you can start then customizing your image for your application. Once that disk image is created with Packer, the image is put on, in this case, Azure Storage, but a disk, or it could be ACR or container registry or something like that. The next step is now to start deploying the actual application in the infrastructure. So here's where Terraform comes in again. The pipeline is called a Terraform. Terraform reads your properties files and your secrets, and then outputs a VM scale set or a Docker container image. And it could be ACS, which is Azure Container Services, or something like Kubernetes. All right, that's a lot of slides, so I'll stop there for a minute and kind of let you know what you absorbed and questions.
So earlier you said for your Terraform, you use a lot of parameterized modules. So are you essentially creating a set of standard deployment kinds of configuration and then just filling in the details for the parameterized values in the modules?
Yeah, so as you look at the DevOps models, we let the operations team write the actual network security gateway or the storage. And the applications team's responsibility is just to create that main TF. So if you know the Terraform structure, you have a main TF, a variables, and an output at the minimum, right? So the main TF just tells you a structure. I need, a VNet. I want to have some type of subnet in there. I'm going to need a network interface. I'm going to need a network security group. I'm going to need a VM scale set or a container. So the application team is only calling the structure of the code and the modules that they need and setting the variables for the application. Once that's built once, every build uses it. You use things like variables from the build itself.
Can you, so I haven't used Terraform for a long time, but the declarative statements used to be quite different for the different cloud providers. Have they become more uniform, or the ability to use modules now kind of eliminated the differences in being uniform?
Yeah, the modules do a couple of things. One, it allows the operations groups to maintain those separately from the actual application dependencies. But you're right, yeah, it's still dependent on the provider. So there's not a lot of common ground there at all. It's based on, so whether you have a custom provider or an AWS provider or Azure, those pieces are going to be custom. What is common though is the fact that you still need a network interface, you still need a security group, you still need firewalls, things like that. So from an application dependency perspective, that name can stay the same, and you just call a different provider based on what you need. So you really focus on the core things of, I need a VM. What's my VM name? What are my tags that I have on it? The fact that what is my DNS name? So those are the things, those are the parameters that you would enter as an application team. And then once your structure's there, then depending on what cloud provider, you would just point to that.
Okay. So you're using. Okay.
It takes a lot of forethought. You're right. It's not like that just happens, right? So one of the things our engineers do a great job here is that's some of the stuff we help our clients with is bringing that experience to the table. Because I can show you the Terraform my code for this demo, and it's not like that, right? It's going to be a single line. What did I even do? All the pieces are there, but you're doing everything manually. So as you get your operations teams up to speed on writing those actual modules, and once again, they're focused on what they're good at. You want the network guy to write the network interfaces. You want him to structure how the traffic's going to be, and let the teams worry about submitting requests for firewalls, but they can still enter, I need these ports, right? But the way the infrastructure is built is based on the operations team model.
Okay, thank you.
What else here?
So Azure artifacts. So you said one of the worries you have is when the Maven Central repo goes down, you no longer can do your Maven builds. How do those artifacts go into the Azure artifact, or how is that automated, or is that manually done to clone things that you need from Central into Azure artifacts?
Yeah, so we would recommend putting it into its own repo within Azure itself. So then you're only getting updates when you want to pull new.
So you do you have your own Maven repo that proxies and caches.
Exactly.
Okay.
So then if that public repo goes down or they change something and you're automatically pulling latest, now you don't break. So this is really a premise around security, and a lot of security teams feel like they lose that structure or that governance model, right?
Sure.
So this allows them, the operations teams, to really focus on the fact that I know my applications are going to be running on our vetted images, right? It's if the fact that they're not just going to put Nginx and leave TLS, SSL open, right?
Can Azure artifacts be a Maven proxy?
What it does is it allows you to kick off Maven builds and things like that. So I don't know that it's actually a Maven proxy now. Not like you're asking. But you can include tools like Ansible on top of this to then do validation of your images, and there's a lot of tools that you can add to complement the stack. And we do see that. I didn't get into that too much because I can make this chart based on some clients, really deep. I was just trying to hit the 5,000 foot level, so you can kind of get the idea of the tools, how they type together.
Yep. Yeah, I don't need to.
So, yeah. I could talk about it all day, so I'm good to go. I just.
Those are all the questions I have right now.
Okay, that's fine. Yeah, great. I know that you asked me a question about Docker and images and things like that. And, did some research on Packer itself. Packer can create container images, but really, you talk about Vagrant and other tools. So we kind of look at it like there's multiple tools in the stack based on what you're going to do. Packer is very good at VM images and handles that very well. But you may want to look at various things based on what type of stack. You can create containers inside of Packer. But there are better tools based on what type of workload or compute you want to use for your workload. Here, okay. I talked about the ability to be able to do this quickly. So one of the things when I was starting to set this up was there's so many pieces. Where do I begin, right? Do I have to create GitHub? Do I have to create all these Azure artifacts and get into all these different layers? And where do you start? So one of the things I stumbled across was Azure has a DevOps demo generator. And what I liked about it is, as a beginner, you're basically able to look at it and go, I have a full stack generated for me. It gives you, and I'll show you in a minute the demo of it, but it creates pipelines, it already has to get reproducible code, it creates all the Azure board stuff. So Azure boards is like a Jira in Azure. So you can have storage, you can have tickets already open. So you basically go through this, you get this whole full experience of the platform without having to set it all up, which is, if you start a project, you get 0 tickets. You have no real view of the flow or how things are gonna work. So one of the things I have here is, I think it's this one. Yes. So this is an example of one of their projects, and you can see, I did build it a couple of times, but they give you bugs, they give you test cases, they give you everything built into it. So when you kick this off, one of the nice things, and I can actually go to it here, is the actual tool. While this isn't necessarily a plug for them, you do get a nice little option. And there's all kinds of things from .NET applications to Java, specific around DevOps, Ansible, Terraform. So you can see based on where you are, whether your company's going somewhere or what you want to do, you get all these options. And like I said, it populates it for you. So while it's not going to be your optimal end state you want to be in, but you get a good idea. You get to start playing with the tools. You get to start playing with the flow of how things work. And like I said, and it's fully populated. I can show you here, you get a dashboard. Here's all your tickets. You get a backlog with components already in it. So you really do get to experience the entire suite. And like I said, you get 9 free, so 10 free, so you can use that to your advances there. All right, where was I on my presentation? Okay, that's my last slide. So what I did want to show you is, so you were asking about the Terraform code, and so I built some sample code here, and I tried to get as much experience as I could, but obviously I couldn't use client files, so I put this together as just showing the example, but this is all the code I needed to build the Packer, right? So when I go in and say, oh wow, I got to build custom images, there's not a lot to it, right? This package here installs Linux, Nginx, and Tomcat. Actually, just Java, JRE. And there's not much here. Most of it, honestly, is your credentials. Set up there. You define the VM you want, some tagging, and then you do your install scripts. So it's not like you're sitting here spending a lot of time. I built this in maybe an hour. So you can really get a good experience. Ultimately, in the end of this, in the Azure, what you end up getting out of it is, where did that go? Sorry. Here. You end up with a VM image, which is, which one of these, right here. So you see, this is my output of my Packer code. I have an image, it's ready to go. I've been able to change configuration files in Nginx. So for example, disable port 80 and things like that. So one nice thing about it is it doesn't take a lot of code. I was able to get this up and running in about an hour. So a lot of the work here, honestly, is thinking through your pipelines, thinking through how to structure your Terraform code, building the packages so you standardize everything. So it's not so much even the code, it's the forethought going into it that you have to, as an organization, make decisions on who's going to do what, and make it so you realize your developers' challenges, what your QA team is going through. So a lot of the structure that we try to present is to help those questions up front. We go in with this experience, this pre-built module, so you don't have to think as much as from the client perspective. So came in here, basically this is pretty basic stuff. I mean, whether you've worked with Ansible or anything else, you get your APT, install Nginx, install JDK. Then I started doing some Tomcat stuff, but ran out of time. So, but you kind of get the idea of how minimal code there actually is to actually create the images and run it. I will tell you though, it takes a while. So while this is supposed to be an automated thing, I was gonna do a live demo, and from beginning to end, it probably takes an hour and 10 minutes. So, you can just think, creating a MySQL database, creating the images, and I literally was like, even if I do a fast forward, there's nothing I could do to demo it within a meetup. So I'm not actually going to demonstrate this working, but I can show you the resources if you have questions on how things are actually working.
So is that time only in Azure or anywhere, like AWS as well?
Packer is HashiCorp, so there's nothing dependent here. There's nothing dependent on Azure at all.
Okay.
So everything you see here, I could run it on my laptop, and I can create. What I am doing though is calling the Azure provider here.
Yeah, no, what I mean is at that time to create those resources, you're saying it takes you over an hour. Is that cloud provider agnostic? Or is that
No,
because of Azure?
AWS is the same.
Okay.
I mean, it just, one time I thought about, like, what am I actually creating? And I think, wow, how long would it take me to go to my data center people and say, I need my whole network, I need a security group, I need firewall rules, I need a custom image, I want it to run on this size machine. And that was a pretty small amount of time. If you've ever worked in an on-prem, that takes 6-7 months. The fact that you can actually build this in an hour is pretty impressive. And that includes SQL database, right? That includes all the disk images to store the repository, ACR to store the containers. So there's a lot there. But yeah, these API calls for the providers are not known to be fast. But you compare that to what it would take for on-prem, and you certainly are coming out. And the theory here too is that this triggers based on some type of action. So with Azure Pipelines, you have triggers. So I can say, when I check in code, I can start this off. I don't have to wait for it. I could do a nightly build, so triggers could be on a schedule. So there's a lot of different variables you could do. So every single morning, my QA team comes in and gets a fresh build of the application's test. So there's not a lot of this, wait for Carlos to click the button and then wait an hour, and you see those funny videos, everybody playing tennis or basketball in the corridor. What are you doing? I'm waiting for my build. But essentially, the idea is that as a developer checks it in, it's then ready for the next stage, an hour later. Especially when you talk about Immutable, right? When you talk about building the entire infrastructure, and that's what we're saying here, there's a lot to build. And like I said, the nice part about it is by automating it, there's no human intervention. You can't have manual approvals within the flow of the pipeline. So know that if I want to have automatic deployment to dev, but before it goes to QA, I want my operations or QA person to be able to check that box. We can do emails or whatever else. Same with production.
So if I were to make a one-line change in my application code that required, can you do an incremental change to an existing image, or do you always have to rebuild the whole?
You can do anything you want, right? I think what we're saying is...
What would be the practical?
Yeah, the idea behind rebuilding everything every single time is you're getting fresh. And when you go from dev to UAT, it's going to be a full build.
Yeah, sometimes you want to run all the tests and you want a response within 15 minutes, let's say.
Well, a lot of these environments too, you can still run locally, right? So whether you're doing shakeout testing or whatever it may be. So that's things, I'll give you an example of that. That's an example of we do things with data wire called telepresence, right? Where we actually have, on my laptop, I can run and I can connect to my Kubernetes cluster. So what ends up happening is I end up putting endpoints in there, and then my laptop calls my Kubernetes cluster. So as far as like a development cycle iteration, sure. But anything that's going to be checked in officially should probably be built and then deployed. So I think, to your point, yeah, developers, every line of code they change, they're not going to want to do a full build. But if you're checking code in, likely you're ready for it to be committed and built. But I guess that could be debated. But
yeah, sometimes you check code in just for security. You don't want to lose it.
true. So I guess once again, there's no fine rule here. Obviously, if you want to have dev not do that, you can do it based on you check it into the next promotion level. So
Packer operate something similar to the layer you have in the Docker.
all the wiring here is done in the pipelines. So whether it be a trigger that triggers the Packer to build the image or anything like that, all the pipeline is the glue. So all you're doing is plugging the pieces in. And like I said, that's where you can introduce things like triggers or any automation you want, or you can say, if it's going into dev, don't build it. Let the developer do it, or you can have a pre-environment for something like that. So this is just a way to automate once you go through your stages, that you know that from dev to QA to prod, the infrastructure is being built exactly the same way for every single one. So there will be models though when you can alter from that, and there's no right or wrong. It's just saying that once you get to a certain point, this type of structure eliminates those other failures or human errors that you may find.
I don't disagree with automating the build of your infrastructure.
Yeah, that's why I wanted to let you know about things like the telepresence that we've even seen, where as a developer, I'm running my own container, and now I'm using telepresence to connect to my cluster. You know, so things like that have been very, very useful as far as productivity and moving forward. So this is a standard Terraform, and essentially what you'll have here is, if you've never seen it, I wanted to kind of show it to you, but we talked about things like creating subnets, creating public IPs, you know, and essentially what you'll end up having is here is all the components that you need to build your infrastructure. And I said, yeah, 80. I did block it, but you know, this was just a template that I put together. Network interfaces. Where else? Here's the virtual machine layout. You can see that, and there's minimal code here, right? It's not like you're saying to build a VM with, I don't know, 8 lines. That's, you know, pretty quick. You know, it doesn't take a lot. And as you see, a lot of these are variables, right? It's not even like I'm writing code. It's just as a variable that's defined above. The prefix, the location, my group, resource group name. I define these once in the code. Then I just use variables throughout. So, you know, when you do play with it, you're probably hard coded at first. Believe me, it's gonna take you everything you can. You don't have to just put it in and copy a template and try to put your variables in. But once you get over that and you start putting actual variables and stuff like that, it's fantastic. Even to the point where you can say things like, oh, on this environment, I want to have a standard DS1 VM image. Maybe in UAT you want a bigger image, in prod you want a bigger. Maybe in dev you only want to have 2 VMs in your scale set, but in prod you need 8. So these are all the variables, and all it is a properties file, parameters file that allows you to change that. Nothing changes in your code, nothing changes in your build, other than the parameters file. So you have a dev, a QA, and a prod parameters file, and it just, all it does is feed this code, and then you can have 8 VMs, you can have 10, you can have, so based on the environment. You can have it so, you know, your firewall rules in dev are more open than production. And understand, those are all parameters. So that's really the mindset you want to try to have when you go into this iteration is, you know, let the automation happen. Let's focus on parameter files. Let's keep our secrets secret. Let's not worry about any of those things as a developer. Let's not worry about any of those things as operations is good at. Let them be good at what they do. Developers good at coding. Let them code. QA is good at testing. Let them test. And by having these CD pipelines automated and done every single time you do a check-in, then you eliminate all those human things that have to happen in between. What else I wanted to show? Went here. Showed that. So then as far as the pipelines themselves, so I was going to show you how that was looking at. So if I was to create a new pipeline here, one of the things you'll see is Azure gives you many, many options, and there's different plugins you can use and things like that. In this case, this is one of those demo apps that I preloaded earlier. So I'll kind of give you a quick idea. This one is the My Shuttle one, which is a Java Tomcat app that was loaded up. And essentially, I know you asked about Docker images, but here they are, right? As I create environments, as I create these things, the pipelines already has all these things to run, ready to run. This app specifically is built for containers, so that's why you get these options. But as the person setting up the pipeline, you can add anything you want. You can, this is where you can add your Terraform code. You can add Ansible checks here. You can add tests, like things like, I want to inject a performance test after it's been deployed before I actually release it, you know, before I switch my DNS or something like that. So you get all those options too. When you go down more, now you can start to see really, I mean, and this is just the glue, like I said, there's no more configuration here other than tying these pieces together. There's triggers, there's all the different components that you'd want to see. when you talk about this pipeline here, it uses YAML to do the structure. This is just a basic push image, but essentially, once again, more code. All you're doing is setting up the structure and gluing the pieces together. There is a visual part of it too, which you can actually drag things around. I like using the YAML just because I can structure it, and I like to be in the user interface. I don't like the user interface that much. It's just clunky. But you know, when I actually look at the YAML files, I can actually know where I am. But there's an option for the UI. Once again, all the different options for ARM templates, deployments, and pieces here. All right, so I'll stop again for questions.
Is the pipeline code similar or the same as the pipeline code used in GitLab? I don't know if they use the same.
I don't know the answer to that. I don't know. Does anybody else have?
You look on the surface, it looks very similar.
I have not used it. I know what you're saying, the GitLab pipelines. I have not used that. Anybody else? Like Kenzan or anything? No. I would assume, I mean, everything Azure's been doing, like Azure Repos, built on Git, right? They haven't been reinventing the wheel, which is part of what I've been impressed with that platform. Some people asked earlier, why are our clients looking to go to Azure? You know, the stack itself, while I find GCP probably the most familiar if I'm an on-prem person to go to public cloud, Google makes the most sense to me. Terms are right, everything seems to line up the way I think. Azure is different. When coming from AWS to Azure, I had to have basically a legend that went, it's AWS in this and Azure in this. I know that sounds funny, but like it took me months to like literally like figure out what are they talking about here. But once you get it, it does make sense. And you know, I think what they're offering, you know, and things, you know, I would say from an Azure perspective, you know, databases is probably one of the areas that they have to improve in. You know, SQL Server is good for SQL Server. You know, and if you're running SQL Server on-prem, there's nothing wrong with that. But you know, when you start looking into the higher performance databases and where to go with that, you know, Cosmos they have is great. You know, and we've been playing a lot with that, but that's no SQL. That's, you know, not really structured for relational database types. As much as they say you can do queries, we haven't really tried that yet. But as far as like running workloads, we've looked at things like Azure Functions and serverless. Very impressed with that model. The fact that I can take a code base, go from Azure Functions to an app service to AKS or Kubernetes, and I don't have to change my code. I mean, it's pretty impressive stuff. They all have their own different working model, you know, and there are different things that I kind of use the term organizational platform, but essentially, no matter what you run your workload on, you still got to account things for like security, automation, orchestration, logging. And if you use Azure Functions, you're going to do it one way. If you're going to use VM scale sets, it's going to be another. But, you know, that's really where they change, not so much your code. It's more the operational pieces around it. That's pretty much everything I had. I don't know if you want to, I can dive into some of the details here as far as more of the repos. The repos themselves let you tie directly into Git. So you're here, you use the triggers, everything gets scheduled there. Your overview, you get your dashboard, you get your summary. It's pretty all-inclusive. I mean, the nice part about this is we're actually using this on a new project, and I will say, like, watching the ability to be able to track all this with the dashboards and the ability for the project managers and the business analysts to be able to actually go in and monitor and get graphs, and it's been pretty nice. So I know that they do compare it to Jira a lot as far as the boards. You know, there's been some mixed emotions there, but I think it may just be a learning curve type of thing. Oh, you can't even see that part of the screen, sorry.
As far as repos and pipelines are concerned, does Azure support the Git flow and building multiple branches to various environments?
You wouldn't even know the difference, Andrew. Like, it's literally, it's Git. I mean, yep.
It's been a pain point for one to look at now, so.
A different provider or?
Well, they use the Jenkins and then the Git for the Git recently.
Okay.
It's a pain.
I know we know more. a break, Jess, and then. I just kept going. Yeah, so I don't know. I mean, I can talk a lot more about this. I just was trying to stay at a level. And like I said, one thing that is nice too with the demos is all the different capabilities, whether it be Docker and it even ties into the Microsoft learning skills. So if you are upskilling and you are trying to get trained, these do give you that. Although I will say in a lot of training, there's not a lot of DevOps questions or any at all, depending on the level, but as we've learned.
Can you use Terraform or Ansible or reproducible just to like configure local machines rather than servers?
Yeah, I mean, for example, the Packer code that I have, I ran on my laptop at first. So I built all of this on my laptop. Even the Terraform, before I even put it into a pipeline, I proved everything out locally. So so whether you create the Packer for your cloud to put it up as an image or locally, you can create a container out of it, you can create a VM image, and then, for example, you can even do Windows images and create that VMD and actually put it right into your any like virtual machine manager.
So the DevOps labs, is that, I missed whether that's just an example of how you can use Azure or whether it's a product within Azure, can't even say Azure. That is, do you pay for time to build and run your tests?
So it depends on how many pipelines you run. So I don't actually know the full cost model. The way we've been working with it is, I know I get 10 free, so this is my personal account.
Right.
At a corporate level, to use DevOps at like a higher level, you get 5 users free for like all the boards and everything, and then I think it's like $6 a month for every user after that.
Okay.
So there certainly is a cost model based on what you scale. But from a small product perspective, you certainly could kick this off and you could do it pretty.
So it is a comparable product to like GitHub or GitLab.
100%, absolutely, yeah. And they're, like I said, you get 5 free. Those 5 can be admins, and then the 6th, 7th, and everybody else. I'm sure there's enterprise level agreements, but from the perspective of just adding individual people.
I just didn't know whether it was like a toy or whether it was a real product.
Yeah, I mean, a lot of these cloud providers are giving you up to so many. Like even if you look at things like message queues or topics, pub submodels, you get a million free, up to $1 million free, or $500,000 free. Or so from a small perspective, you can certainly apply a lot, and for little dollars, it's when you start scaling that they actually end up costing. But what a lot of people don't understand too is it's not just one queue; it's usually many queues. So then you start adding all those up across. Especially if you go some type of event-driven model or something like that.
What's NuGet?
It's just another package manager. It's no different than things like NPM, or all it is it creates a package. So it's not.
Just hadn't heard of it. What is it typically used to package?
Things like basic artifacts and like images, so you could build your application images from it. So it'll do things like compiles and builds, and it'll call all the things, but basically what it does is it manages your package itself. So as you create a packaged image, then you can use that to call in when you use things like Packer. So it's
just I think of Maven as being primarily Java, and then
code, yep.
Primary JavaScript, HTML, and so I don't know if NuGet had a particular community like.
Well, as you look at things like .NET code and things like that, there's different builds. So, it's not, to your point, Gradle and Maven are going to be for Java-based code, right? Then you have other, maybe like Visual Studio type of code build. You create an image and it manages that image for you.
Okay.